Hi, I'm Dr. Raj Shah of Math Plus Academy, and this treat is called integer squares. Imagine you have a lattice of dots like this, a square lattice of dots that goes out in all directions as far as you want. Here's a little section of that grid, and all I'm going to do is draw squares on here where every corner of my square has to lie on one of these black lattice points. So very simply, you could just draw probably the smallest square you can think of is that one right there. And for the purposes of this math treat, we'll call this square, we'll say the area of this square is 1. It's 1 unit on both sides. 1 times 1 is 1, so the area of that square is 1. Great, so I've made an area 1 square. In fact, maybe I'll just go ahead and label this area 1. Cool. Let me make another square. Let's see, how about I go a little bigger this time and make this square. Okay, well this one's 2 units tall and 2 units wide. 2 times 2 is 4. This we'll call a 4, right? So I've now made squares of area 1 and area 4. And you could keep playing around with this, and I'm sure you'll get many different sorts of areas. Now, something that sometimes people miss is that all of our lines, our sides of our squares, they don't all have to be up and down and left and right. They can actually be diagonal, and we can make what I like to call tilty squares. For example, I might draw this as a side to start. Now, can I turn that into a square? Well, let's see, I went over 2 and up 1. Do any of the other points give me a 90-degree angle with that? I believe I can do this, and then this, and then that. And that should be a square. You should double check that. Remember, think about what you know about squares. They have 4 equal sides. There's 90-degree angles, whatever other parameters you know. See if you can convince yourself that that's a square, assuming you've drawn your grid very precisely or you're using graph paper. So I think that is a square. Now, what is the area of this square? Well, it's a little tricky to figure out, but one way I might do it is to sort of cut it into pieces and think about it that way. So let me try that. Let me cut it in. I see a square right here on the inside, which is of area 1. We know that. But I also see a triangle right there, and a triangle right here, and a triangle right here, and right there. So there's these 4 triangles. And if I look at it carefully, all of them are 1 unit wide and 2 units tall, right? 2 units wide, 1 unit tall, 2 units tall, 1 unit wide. So they're all the same. They're just rotated around and maybe even flipped around a little bit. But they're all the same size, the same dimensions, and they're all right triangles. They all have these little right angles in there. So the area of those is going to be the width times the height divided by 2. So 2 times 1 is 2, divided by 2 is 1. So these are all worth 1. So 1, 2, 3, 4, and that one's worth 1. So the whole thing is worth 5. So this green square has area 5. Now that's just one way you could find the area. There are other ways to do it. You can count the dots on the perimeter and on the inside, and that's a different math treat that we worked on. So now I've made a 1, a 4, and a 5. And I'm starting to wonder, can I make a square with area 2, or 3, or 6, or 7, or 8, or 9? What are all the integers? What are all the whole numbers here of areas that I can make on this grid? Are all numbers possible? Are certain ones impossible? That is your challenge for this math treat. Start drawing squares, figure out their areas, write them down, and see if you can make one of every size. 1, 2, 3, 4, 5, 6, 7, and so on. And can you make ones that aren't integers in area? I don't know. So those are 2 interesting questions for you to think about. As always, just have fun playing with the math.